Hello everyone and welcome back again to another new video of DeltaMind. Today in this video we will be discussing about imaginary numbers. Well, we are already aware of real numbers. Real numbers are the numbers which we encounter in our daily lives. They exist on the real world and can be represented on the number line. But you see, there also exists numbers which doesn't even exist. Yes, you heard it right. Imaginary numbers are the numbers which has no existence at all. Yet they are studied and used in real life. Well, what is the point of studying something that doesn't even exist? Let's find out in this video. So first, let's consider the equation x squared plus 1 equals 0. You see, when we solve this equation, we get x equals to under root of minus 1. But wait, a positive squared is positive number and a negative squared is positive as well. So the square root of negative 1 doesn't even exist. So people thought that this equation had no solution. But it was seen not only this equation but many quadratic equations which had negative discriminants gave same kind of numbers with negative numbers inside square roots. This fact was first noticed by mathematician Girolamo Cardano while he was working with cubic equations. But later, mathematician Leonhard Euler introduced the concept of imaginary numbers. Actually, he represented a new number called I to represent the square root of negative 1. Alright, so first let's consider the equation we were working on before. X squared plus 1 equals 0. When we solve this equation, we get x equals to I, where I is the square root of negative 1. But not only this equation, we can use them for any quadratic equation with negative discriminants. Just consider this equation. X squared plus 2x plus 5 equals 0. When we use the quadratic formula to solve this, we get minus 2 plus minus under root of negative 16 by 2. Now, we know that I equals to square root of negative 1, where I is the imaginary unit. So, we can write square root of negative 16 as square root of 16 times minus 1, which is root 16 times root minus 1 or 4 times I. We substitute back into the original equation, we get x equals to minus 2 plus minus 4i by 2. Now, if we divide both terms in the numerator by 2, we get x equals to minus 1 plus minus 2i. So, the complex solutions to these equations are minus 1 plus 2i and the other root is minus 1 minus 2i. Well, with the rise of imaginary numbers, there came along a whole new number system called the complex numbers. And not only a whole number system, but it gave rise to a whole new branch of mathematics called complex analysis. Well, a complex number z is defined by x plus iy, where x is the real part and I times y is the imaginary part. But however, this is not the topic for this video. In our future videos, we will explore each and every concept of complex analysis in detail. Meet you in the next video. Until that time, bye.